In section 6.3, we learned that we can prove that triangles are similar by angle-angle similarity. In section 6.4, we're going to see two more ways you can prove that triangles are similar, and those are by side-side-side and side-angle-side similarity. So let's start with the first theorem, theorem 6.2. It's the side-side-side similarity theorem. So you're still going to abbreviate it as SSS, just like we did when we were proving triangles congruent a couple chapters ago. It states, if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So if you can prove that the ratio of AB over RS is equal to the ratio of BC over ST, and that's equal to also the ratio of CA over TR, so if all three ratios are the same, so side, 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 then the two triangles are similar. Now let's put that theorem to use. So here's example number one. Is either triangle PQR or triangle STU similar to triangle XYZ? So we will be comparing these two triangles to triangle XYZ. You need to also keep in mind as you're doing this that you need to do it in corresponding order. So PQ compared to XY or QR compared to YZ. So let's get to it. Let's first do PQR compared to XYZ. So PQ would correspond to XY according to how it's listed above. So that would be 35 over 25, which is equal to 7 over 5. So if all of the other ratios are 7 over 5, then we would know that the two triangles are similar by side, side, side. Next, we have QR, which is here, compared to YZ, which is here. So that would be 21 over 15. So I would divide both of those by 3. So 21 divided by 3 is 7, and 15 divided by 3 is 5. So we have 7 over 5 for that one as well. And then finally, we'll compare PR to XZ. So we would have 42 over 30. Divide both of those by 6, you'd have 7 over 5. So you would know that triangle PQR is similar to triangle XYZ by side, side, side similarity. Now let's check to see if triangle STU is also similar. Again, keep in mind that we need to go in corresponding order. So let's compare ST to XY. So we have ST is 15 and XY is 25. In lowest terms, that would be 3 over 5. So we know that if we compare other corresponding sides and we don't get 3 over 5 as our ratio, then we know that the two triangles are not similar. So let's next check TU compared to YZ. TU is 20 and YZ is 15. So we can already see that something weird's happening because before we had a smaller number over a bigger number and now we have bigger over smaller. So 20 over 15 in lowest terms would be 4 over 3. So automatically, since we got a different ratio, we know that triangle STU is not similar to triangle XYZ. And now let's look at example number 2. Find the value of x that makes triangle XYZ similar to triangle PQR. So again, we need to find an x value that would make all of these sides have the same ratio so that we could prove that the two triangles are similar using side, side, side similarity. So we're going to set up a proportion. Since we already know that the ratio would be 20 over 30, which is 2 over 3, I can set up the proportion to be 2 over 3, which is pretty simple, and then compare it to another pair of corresponding sides. So I could have x plus 6 over 21 or 12 over 3 times x minus 2. I would choose the x plus 6 because it just looks a little bit more simple compared to the 3 times x minus 2. So I'm going to set up my proportion to be x plus 6 over 21. So then I would just cross multiply. So 2 times 21 is 42. And then I'd have to take 3 times x plus 6, because remember, when you cross multiply, you can't just take 3 times x or 3 times 6. You have to take it times both of them. So I would distribute. So I'd have 42 equals 3x plus 18. Subtract 18 from both sides. And I would get 24 equals 3x. Divide both sides by 3, so I get x equals 8. And that would be my final answer. I do not have to set up a proportion comparing the 12 to the 3 times x minus 2. I just used what I was given, and I used what was more simple to solve for x. And once I find x, then I am done. So far, we have angle-angle similarity and side-side-side similarity. Here's a third way to prove that triangles are similar, and that is by side-angle-side similarity. So just like when we did when we proved the triangles were congruent, we can abbreviate it as SAS. It states, if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. So again, you have to have the included angle. So angle X is congruent to angle M. So the sides we use have to include those angles. So it'd have to be XZ and MP and XY and MN. So if those proportions are equal, when I write them as ratios, then I can prove that the two triangles are similar. Let's put this theorem to use in the next couple examples. So here's example number 3. You enlarge triangle XYW to triangle JHK as shown. Is triangle XYW similar to triangle JHK? So don't be confused by this P. That is just the point in which I enlarge things. So don't be confused by the dotted lines or anything like that. That's just showing you how it's being enlarged. So you're going from this smaller triangle to this bigger triangle, and we want to know if they are similar. So first I notice that this angle is congruent to this angle. So if I'm going to compare these using side angle side similarity, then I need to use this side compared to this side and this side compared to this side, since this would be the included angles. So first I want to state that those angles are congruent. So it'd be angle YWX is congruent to angle K. There's only one angle K there, so I can use just one letter. So now if I was going to use side angle side, I need to show that this side over this side is equal to this side over this side. So first let's do 18 over 27, which in lowest terms is 2/3. And then let's do XW over JK, and we can see we have those units down here. So we would have 16 over 24. And in lowest terms, that would be 2 over 3. So since I have the included angle and the two sides sharing those angles are proportional with a ratio of 2 over 3, I can now state that triangle XYW is similar to triangle JHK by side angle side similarity. And here's a nice summary showing all 3 ways to prove that triangles are similar. We only have 3 ways. We have angle-angle similarity, side-side-side similarity, and side-angle-side similarity. What I like about this graphic is it shows you with pictures what exactly you would have to prove are congruent or proportional in order to use that postulate or theorem to prove that the triangles are similar. So again, I would print this out, cut it out, and put it in my notes. And here's our last example, number 4. Tell what method you would use to show that the triangles are similar. So if I want to show that triangle SRT is similar to triangle PNQ, you can see here I have an angle congruent to another angle, then I have 2 pairs of sides that I would prove are proportional using the ratios of the sides. So in this case, I would use side angle side similarity. For part B, I can see here that I have all of the sides that I can compare, since this side would be congruent to itself. So if I wanted to prove that triangle XZW is similar to triangle YZX, then in this case I would use side, side, side similarity. And that's it for this section. Make sure you jot down anything you don't understand that we can cover in class. Also, let me know if you want me to print out any of these for you to put in your notes, and we'll see you in class.